All right, kiddos, today we're going to talk about some 45, 45, 90 right triangles. This is the first of these special right triangles. If you will make sure to take the time now or when we are finished to update your table of contents, that will really help your notebook grade. Remember, do not just put notes in there. You got to specify what the title of the notes are. Today's objective is to use and apply the properties of 45, 45, 90 right triangles to solve real-world math problems. All right, so I literally want you to take a minute and hit pause after I preface this. These are all squares, so what I want you to do is I want you to think about it like this. If these were right angles, and because this is a square, and they tell you that, and because of our properties of quadrilaterals chapter, we know that all these sides are a square. If this bottom side is 4 centimeters, we know this is 4 centimeters. So I want you to, we'll just call them X, Y, and Z. I want you to hit pause, and I want you to take a minute, and I want you to use the Pythagorean theorem to find the hypotenuse lengths of X, Y, and Z. All right, welcome back. Hopefully using the Pythagorean theorem, I'm going to do one, but not do all of them. You had 4 squared plus 4 squared equals x squared. That is a horrible square. Equals x squared. So this is 16 plus 16 equals x squared. Because I know what's coming up, I'm going to write this as 2 times 16 equals x squared. And when you solve for x squared, you get x equals the square root of 2 times 16. And because I am a rock star at simplifying radicals, and so are you, you cannot take the square root of 2, but you can take the square root of 16. So I know in this particular problem that my hypotenuse x is going to be 4 square root of 2. Now, if you did this for the other two triangles, you should have gotten 6 square root of 2 for this hypotenuse, and you would have gotten 8 square root of 2 for this hypotenuse. So when we think about math as a study of patterns, is there a way, if I have the leg length of a 45, 45 or an isosceles right triangle, could I find the length of the hypotenuse without having to do the Pythagorean theorem every single time? So if we think about it, we took and we compare, here's a 6 and here's a 6, here's a 4 and here's a 4, here's an 8 and here's an 8. So really, if the triangle is isosceles right, or our special 45, 45, 90 triangle, we really took the leg and we multiplied it by the square root of 2. All right, so if we are looking at this 45, 45, 90 right triangle, and we think about what's going on, this is a leg, this is a leg, and this is a hypotenuse. And this next set of rules, which I don't love calling them rules, but I don't have anything better to call them, so that's what we'll call them. If we're going from the leg to the hypotenuse, that means we're going to take the leg and we're going to multiply it by the square root of 2. So when we're getting bigger, and we all know that the hypotenuse is the longest side of the triangle, we're getting bigger, so we're going to multiply. If we reverse that and we're going from the hypotenuse to the leg, we're undoing this process. So we're going to take the hypotenuse and we're going to divide by the square root of 2. So basically our multiplier or divider for a 45, 45, 90 is always the square root of 2. And if we're getting bigger, then we're going to multiply. And if we're going backwards and we're getting smaller, then that tells us that we are going to divide by that square root of 2. All right, so let's put this into some problems. All right, so find the missing variable. So the first thing you need to do is realize, hey, I have a 45, 45, 90 triangle, and that's true for both of these examples. This is going to become important because our next section is 30, 60, 90 triangles, and they have different rules. So we just need to make sure we know what we're working with. When I look at these properties, these triangles are isosceles, which tells me very quickly that I have another leg length of 8. So in this particular problem, y is 8. I have my leg, and I'm going to my hypotenuse, which means I'm getting bigger, which means that I need to multiply. So to go from my leg to my hypotenuse, x is going to be the leg length times the square root of 2. Sometimes there is more math to do, and sometimes there is not more math to do. Lucky for us, that's all there is to this problem. All right, looking next door, I have a leg of 10, which means my other leg is 10 because I have a 45, 45, 90 right triangle. Same thing, I am going from my leg to my hypotenuse, which means I'm getting bigger, and we multiply when we're getting bigger. So I'm going to take that leg length and I'm going to multiply by the square root of 2. So that means that the length of u is 10 square root of 2. If they were all that easy, life would be great. And really, applying the property is that easy, but just sometimes we have to simplify radicals. So here we go. This time I have my hypotenuse, and I'm going backwards to get my leg. So this time I have my long side, I'm going to my short side. So because I'm getting smaller, this tells me I need to divide. So that tells me that x is going to have the same length as y because this is an isosceles right triangle, but I'm going to divide by that square root of 2. Our properties of radicals will not allow us to leave a radical in our denominator. So because I'm dividing by square root of 2, that means I need to rationalize my denominator. So I'm going to multiply by the wacky form of 1. And in this particular problem, x is going to equal y, and I have 3 square root of 2 in my denominator, or in my numerator, sorry. And if I take the square root of 2 and I multiply it by the square root of 2, I get the square root of 4, or you can think of it as the square root of 2 squared, however your brain works. And in both cases, we have a denominator of 2. Since the 3 and the 2 can't reduce, I am done with this problem. All right, another fun example. So in example 1D, you have a leg that's 5 square root of 2, which tells me my other leg is 5 square root of 2. I'm going from my leg to my hypotenuse, so again, I'm getting bigger, which means I'm going to multiply to get bigger. Because this is a 45, 45, 90 right triangle, I'm going to take my leg length that I have. I'm going to multiply it by that multiplier of radical 2. So if I have 5 times the square root of 2 squared, the square root of 2 squared is just 2, which tells me that A is going to be 10 units long. Okay. Biggest thing, process stays the same, just the simplifying of the radical will be the only part that you have to spend any extra time with. All right, E and F, I want you to take a minute. I want you to hit pause. I want you to work these out on your own. And then when you're finished, I want you to rejoin me. All right, welcome back. If you caught this was a 45, 45, 90 right triangle, you know your two legs are congruent. To find x, we're getting bigger, so I'm going to take the square root of 10. I'm going to multiply it by my multiplier of radical 2. I'm just going to break this down. 10 is 5 times 2, and I'm going to bring this 2 down right here. This allows me to multiply 2 times 2, or 2 squared. So 2 times 2 is 4. The square root of 4 is 2. So x is going to equal to radical 5. The simplifying of radicals, we all see them a little bit different. So sometimes I'll try to show you some shortcuts that will help. So don't make numbers bigger and then turn around to break them down. I just leave them broken down from the beginning, but whatever you choose to do. All right, for F, both of these sides are square root of 6 over 2. I'm getting bigger because I need my hypotenuse, which means I'm going to multiply the square root of 6 times over 2 times the square root of 2, which is technically over 1. Again, I'm not going to make these numbers bigger. I know that 6 is 3 times 2, and I already have a 2 going on. So 2 times 2 is 4. The square root of 4 is 2. I can't do anything with the radical 3. So bring the 2 over from my denominator. These 2's cancel, so the length of side x is simply square root of 3. All right. Now, some application type problems. The legs of an isosceles right triangle are 7 square root of 6. What is the length of the hypotenuse? The biggest thing, and you really wouldn't have to draw this picture if you could understand it from the problem, but it says your legs are 7 square root of 6. They tell you your triangle is isosceles right, so either you can think about that as my legs are congruent, which also means that my angles are 45, 45. They want the length of the hypotenuse, which means, for all practical purposes, that I'm getting bigger. And anytime I'm getting bigger, that tells me I need to multiply. So 7 square root of 6 times the square root of 2. Again, I'm not a fan of making numbers bigger and then breaking them down, but if you did that, some of you might get this as 7 square root of 12. And using the simplifying radicals procedure, is there a perfect square that goes into 12? Well, yes, there is, Ms. Schwartz. So 4 times 3 is 12. Going to bring down my 7 because so far I have done nothing with that 7. If I look at my 4, I can take the square root of 4 and it is 2. When I look at my 3, I can't do anything with that 3. So in the end, I get 14 radical 3. And again, it's the same process over and over and over. You just have to figure out whether you're multiplying or whether you're dividing, and you need to make sure you have a 45, 45, 90 triangle. Okay, so example 3, the diagonal of a square is 12 radical 10 inches. What is the area of the square? So here's the thing, right here, they want the area. So if I find the area of a square, that means I'm going to take length times the width, or some of you will think of the area of a square as side squared. So in the end, or in the beginning, when they give you this information about your square, and because this is a square, I know I have a 45, 45, 90 right triangle, they actually come in here and they give you your diagonal. So now I have to think, okay, looking at what I need, area is side squared, so I have to have my sides. So because this is a 45, 45, 90 triangle and I need my legs, I'm getting smaller. And when I get smaller, that tells me I'm going to divide. So if I take, and I'm just going to call this, I'm not even going to get a variable. If I take 12 square root of 10 and I divide by the radical 2, because this is a 45, 45, 90 right triangle. Remember that inside kids play with inside kids. So when I look at this, 2 and 10 are both underneath the radical, which means I can simplify those. So 10 divided by 2 is 5. So this becomes 12 square root of 5. Now, this is not my answer. Remember, the problem asked me to find my area. So the area is length times width, or side squared, whichever one you want to think about it. I'm going to use side squared. So 12 square root of 5. And I put parentheses around that because it's a grouping symbol and I have more than one thing going on. So I have 12 and I have square root of 5. So this grouping symbol or the parentheses is important because I'm not only going to square the square root of 5, but that squared also applies to the 12. 12 squared is 144. Square root of 5 squared is 5. Not gonna lie, I am getting my calculator out for this. 144 times 5 is 720 because they asked for area, and in my problem they gave me my units as inches. This is going to end up being inches squared. All right, and the last problem for today, I'm going to leave this one open-ended because this is what we're going to start talking about in class tomorrow. So I want you to explain in words using pictures how to find the leg of a 45, 45, 90 triangle if you have the hypotenuse, and where does that 45, 45, 90 right triangle come from. Hope you have a great rest of your day, and I look forward to seeing you in class tomorrow.